Hello everyone, welcome back to Matrix lecture series. In the last lecture, we begin with a new topic, operations on matrices. Today, we are going to continue the same topic. In the last class, we discussed some properties of matrix addition. In continuation, we are going to discuss property number 3rd and property number 4th. So what does it say? Property number 3rd says that in case of matrix addition, there exists a additive identity. Now, what is identity? Identity is basically a matrix. In general, identity is not a matrix. But since we are dealing with the matrices, therefore I am able to say that identity is a matrix such that when I add it with another matrix, I get the same matrix. Why I am saying that when I add, it is because I am considering the property of matrix addition. Therefore, I am saying when it is added. So, as you can see here also, that if I add a matrix such that the matrix when added give me the same matrix A. Okay, when I add some matrix to my given matrix, I get the same matrix. Such type of matrix is the identity matrix. Now you can yourself tell me what the identity matrix will look like. Suppose my given matrix is 1 2 3 4. Now what should I add to this matrix so that I again get 1 2 3 4? The answer is very simple. Just add 0. Just add a matrix in which all the entries are 0. So I get a matrix which when added with any matrix given to me, I get the same matrix again. Let's say instead of this matrix, I have some another matrix like this. Then here also when I add according to the rule of addition, according to the rule of matrix addition, then again I get the same matrix, right? So here in my case of additive identity, what is the additive identity? The additive identity is this one. Now one thing that you need to keep in mind is that this is not fixed. I mean, I have written here the identity of 2 cross 2. Maybe the given matrix A can be of order 3 by 3. So in that case, my identity will look somewhat like this: 0 0 0 0 0 0 0 0 0. This is of the order 3 by 3. Okay, because only then the operation of addition is applicable. Operation of addition is able to be applied, right? Now move ahead to the next property, additive inverse. Now according to the definition of additive inverse, it says that what matrix should be added to a given matrix so that I get the identity matrix. Again, let's try to understand it with the help of example. If I have 1 2 3 4, this is, suppose this is my matrix A. Now what should I add in this matrix so that I get this? Why I am aiming to get this matrix? Because this is my identity matrix, right? This is my identity matrix. This is the identity matrix in case of addition. Remember, this is the identity matrix in case of addition. In case of multiplication, we will see which is the identity matrix. Okay, so if A is this matrix, then what should I add so that I get 0 0 0 0 at all the position? Your answer will be this, right? Just simply add them with their negatives, then I get the 0 0. Basically I am getting the identity. This is what the definition of additive inverse is. Basically, if I have some matrix A, then the additive inverse is minus A, which when added I get 0, right? Hope it is clear to you. Now let's move ahead to the properties of scalar multiplication of a matrix. Basically, these are the very trivial ways in which we multiply. If k is some scalar which is multiplied with a plus b, then obviously we will get ka plus. okay, this is not a thing, sorry. If I multiply k with a plus b, then what I get? I get ka plus kb. This is very trivial thing, right? Similarly, second, if we have two scalars k plus l, consider it as one scalar. Instead of two scalar, let's say my k plus l is some m. Okay, so basically what it is written here, it is written here as k plus l into a, which is nothing but m into a, right? And what is m? M is k plus l. So it is again very trivial that this k plus l times a becomes ka plus la. This is clear. Now this one actually, in this and this, it is the author has shown that how this result in this and this result in this. We can very easily understand this or prove this or verify this with the help of an example. Let's take an example. Suppose my A matrix is let's consider a simple matrix 1 2 3 4. This is my matrix. Okay, if if my k is 1, my l is 0, it can be anything, right? So what I get, I need some space. Okay, I can write here. Okay, k plus l is 1 plus 0, right? 1 plus 0 is when I multiplied k plus l, which is equals to 1 with a. What I get when I multiply basically 1 with a, I get this same matrix, and this is also equals to ka plus la. Let me write it in another page. Okay, now yes, I have a new page here, so I can explain you with a very easy example. So what we are actually trying to show, we are trying to show that my k plus, let me write it from here. Okay, after this it will be very clear to you. K times a plus b, I have to show that this is ka plus kb. Actually we are trying to understand it with the help of an example. Okay, and this is equals to ka plus la, right? Now let's see first one. Suppose for example, for consideration, for example, I take my k as 2, any number, my l, let's say it is 3. Okay, my a is a matrix which look like this 1 2 3 4. My b is a matrix which look like this 2 1 4 3. Okay, now first property says that k times a plus b. Let me first find a plus b. What is my a plus b? My a plus b is 3 3 7 7, right? And k times a plus b is, what is k? K is 2. So 2 times this is what? How I define the multiplication of a matrix by a scalar? Just simply multiply the scalar with each and every element or each and every entry in the matrix. So when I multiply 2 with all these, what I get? I get 6 6 14 14, right? Now consider the RHS. Let's see whether we are getting the same answer or not. This is what we get by this. Let me write RHS here. So Ka, that is 2 times this A matrix. 2 times this A is 2 4 6 8, right? 2 times B is 2 4 8 2. I have to multiply by 2 na. So 2 to the 4, 2 1 the 2, 2 4 the 8, 2 3 the 6. If I add both of these two matrices, then what I get? I am writing it small here. If I add these two, basically if I add this and this, what I get? I get 4 plus 2 which is 6, 4 plus 1, which is here should be 2, here it should be 2, because 2 into 1 is 2, right? So 4 to 6, here 6 and 8, what is 6 and 8? It is 14. This is LHS and this is my RHS. Okay. So 14 and this is also 14. Now you can yourself see that this LHS and this RHS are same. That is, this thing and this, the addition of both of these, this is equal. So I hope this property is clear to you. Now let's understand this property with the help of an example. Let my K, L, A are all these same. Let me erase this. So what is my LHS? It says K plus L into A. So K plus L, what is my K plus L? 3 to 5. I have to multiply K plus L with A, which is 5 times A, right? So multiply 5 with each and every term. 5, 10, 15, 20. Okay. Now what is my RHS? My RHS is, this is my LHS, this is my LHS. Okay, what is my RHS now? My RHS says that KA and LA should be equal. KA and LA should be equal. Let me create some space. So my LHS is this one, right? This is my LHS. My RHS says that KA, which is equals to, what is KA? 2 times all these numbers. So 2, 4, 6, 8, and my LA, which is equals to what? 3 times all these number. 3, 6, 9, 12. If I add both of these, what I get? I get 5, 6 and 4, 10, 9 and 6, 15, 12 and 8, 20. So this is my RHS, this is my LHS. Are they same? Yes, they are same. Hence this property is also holding, right? This is also holding and this is also true. I hope this is clear now. So here it is saying that this property and this property are the two properties of the scalar multiplication of a matrix. Here in this and this point, the author has shown that how they are equal. We have understand this, how they are equal, with the help of an example. Here the author has taken a trivial, a general case actually. Okay, so hope it is clear to you. Now let's understand this example. Example number 8. What does it say? It says that we are given A matrix and B matrix and we have to find X matrix such that this is equal. Now this is a very important application of the matrix, of the properties of the matrix addition. This is very important. See what we are given. We are given this. What we have to find? We have to find X matrix. So a very general thinking says that simply make X alone here. So if I do some calculations, then it will look like this, right? Now one mistake that most of you will commit is that you will directly say from here that simply 3x is equals to 5b minus 2a. You will basically shift this 2a to right hand side. This is the thing that most of the people will do, but this is a very incorrect way if I speak very technically, because such way of shifting the position is not present in case of matrix. In case of real numbers we can do this. While solving the equations we can do this, because at that time we deal in the real numbers. But here in case of matrices, such shifting is not a rule. This is not a rule. The correct way of doing this is like this: adding both side a matrix which is minus 2a. Why it remain equal? The reason behind is it is commutative. Which is what is commutative? The matrix addition is commutative. This is the reason that they remain equal even when I add minus 2a, right? This is the reason, and this is the correct way of doing it. Now since we have seen here that for a the additive inverse is minus a, and when I add a with minus a, what I get 0. That is identity. This is not actually 0, but this is the notation to denote the identity matrix or zero matrix. So here you can see when I add 2a with minus 2a, I get 0, right? So in this way we can basically shift. Exactly, we are not shifting, but this is the way in which we show that yes, the way is also correct as the way of shifting. Technically you are not supposed to do shifting there. You are supposed to do in this method only, in this way only, by writing the correct property you have used, that is commutativity. But in your mind, in your heart, you can take it analogous to the equations of real number, that yes, there we were shifting it, and here we are basically adding the additive inverse. Hope it is clear to you. Now next further it is very simple. When I add the identity matrix with 3x, I again get 3x. Why? The reason is this: additive identity. Any matrix you add it with identity, you get the same matrix A. Okay, this is the reason which is used here, or this is the property which is used here. So when I add 3x with 0, I get 3x. In this way we are able to make the x alone. What is x here? Remember, the x is a matrix. X is not any number or not any scalar, it is a matrix. Now this is very simple. This particular thing is very simple to do. Just simply multiply B matrix with 5, the scalar 5, multiply matrix A with scalar minus 2, add them. What I get by adding them? I get this, right? And this is equals to what? This is equals to 5b minus 2a, right? After doing this operation, I will multiply it with the scalar 1 by 3, and what I get as a resultant? I get my x matrix. You can see here, this is my x matrix. This is very simple, just a little bit calculation, otherwise it is very simple. Just you need to understand the concept here. Here we cannot simply shift it. We have to use the property, the commutativity, the existence of additive identity, the existence of additive inverse. This is the real logic behind doing so. I hope this example is clear to you. For today it is enough. We will see further examples and discuss the another concepts of multiplication of matrices in the next video. So till now it is end of the video. In case you have any doubt, please put it in the comment section. You can also connect with us via various social media handles. Thank you.